The thermal readings on auxiliary systems 3 and 4 are slightly elevated.
It seems to be stabilizing now, well within the pre-flight parameters.
From the outside, the entire system of the narrow-body aircraft resembles a massive electronic maze, where thousands of wires sensing. Even passengers who regularly fly through the sky rarely imagine that behind every small button in the cockpit, the male engineer studies the pressure indicators as if listening to the heartbeat of a gigantic living organism. These are times. The more people look into the world of modern aviation, the more they feel that aircraft can only exist because of increasing technological. Yet within all those layers of control appears a question that has troubled many aerospace engineers for years, that if aircraft systems are truly so complex. Procedure complete on panel 12. Move to the next section.
That creates a strange paradox within aviation, where the more people look at the overall structure of an aircraft, the more overwhelming it appears.
No aviation system can survive long-term if even maintenance personnel cannot understand its operational logic within the shortest possible time.
West. That is the moment when the central question of the video becomes clear: whether modern aircraft systems are truly built from complexity.
Under normal operating conditions, the narrow-body aircraft with matte gray metallic surface, no logos and no markings, does not. Dreams of changing data continue moving, but the core purpose revolves around only one objective: maintaining stable and predictable fuel flow.
Even the flight control system, which is often considered the electronic brain of the aircraft, is actually divided into very small tasks.
Workers aged 22 to 25 inside the maintenance hangar behind the terminal inspect each sensor through short, repeated procedures. Thousands of complex connections are actually built from extremely basic principles such as checking power, confirming signals, and verifying responses.
What surprises many people is that most aviation systems are not trying to create infinite intelligence, but instead are trying to minimize misunderstandings between components operating together. The easier a system is to explain to others, the more stable it becomes in real-world operation.
Aircraft are not designed to become mysterious, but instead are designed so every action can be traced, inspected. When the aircraft is powered for testing inside the maintenance hangar behind the terminal, countless systems activate simultaneously, yet every reaction unfolds in a fixed sequence. That seemingly normal operating condition begins to create a major question, that if everything underneath has been simplified, then why does aviation still require? The true complexity of aircraft does not lie within individual components, but within the requirement that too many simple systems must coordinate perfectly together. Toters. An individual sensor may be very easy to understand, but when hundreds of sensors send data simultaneously in real time,
most aviation failures do not come from a component that is too complicated, but from small connections between systems that appear very simple.
That is the moment when an important contradiction becomes clear, that the more serious the problem becomes, the more aviation returns to extremely simple operating principles in order to maintain control.
Once a system becomes too difficult to understand, people begin losing the ability to predict outcomes, and that becomes the most dangerous moment for an aircraft operating in the sky.
Because of that, aviation designers do not attempt to make systems more complicated in order to display technology, but instead attempt. During moments of extreme pressure, pilots do not need hundreds of options, but only one action that is clear and trustworthy.
That realization causes many people to understand that the truly dangerous thing is not simplicity, but a system so complicated that no one can understand.
Phalanx. At this point, the question of the title is no longer simply whether aircraft are complicated, but why the entire aviation industry
The core reason lies in the fact that aircraft are not designed to impress people, but are designed to minimize the possibility of mistakes when humans and machines must coordinate under extreme pressure. An ideal aviation system is not the one with the most functions, but the one that allows pilots to immediately understand what action is needed.
The control panels are always organized according to extremely consistent logic, even though the underlying technology continuously changes across generations.
The Caucasian female engineer, aged 22 to 25, demonstrates that even the most advanced automated systems always contain simpler
signets. Workers aged 22 to 25 rotate through inspections of each equipment cluster. Because in aviation,
The simplicity hidden beneath aircraft systems is not the simplicity of having less technology, but the simplicity of organization. So 3. If a system attempts to solve too many problems simultaneously, it will begin producing unpredictable reactions. And that is exactly. Most algorithms underneath are continuously answering very simple questions: whether conditions are stable, whether conditions are safe, and whether intervention is necessary. What keeps modern aircraft operating reliably is not because they possess infinite intelligence, but because they constantly attempt to transform dangerous situations into decisions.
Every aviation technology ultimately must serve clarity rather than mystery.
That is the deepest reason why simplicity becomes the true foundation beneath aircraft systems that appear overwhelmingly complex while flying across the skies every day. Compared with many other technological industries, aviation is different because it is never allowed to depend on systems that only function well under ideal conditions. A phone application can fail and later receive updates, but a narrow-body aircraft with me. Because the consequences are so enormous, everything in aviation must be simplified to the point that humans can still understand and manage it.
The African-American female engineer aged 22 to 25 compares a good aviation system to a clear conversation.
Those repeated movements demonstrate that reliability is always built from consistency rather than complexity. Incidents. What appears complicated to passengers is actually the result of thousands of decisions focused on simplification.
A system that is too complicated to explain is often also a system too dangerous to trust completely. And that is why the most frightening thing is not a simple system, but a system so intelligent that humans can no longer understand what it is thinking. The final answer to the title of this video lies in the fact that modern aircraft systems are not safe because they are complicated, but
Aviation does not attempt to create machines capable of doing everything, but instead attempts to create machines that always respond in the most understandable way during dangerous situations.
Flap settings look good on my end. Confirmed. The hydraulic pressure is steady. That moment demonstrates that the true progress of technology does not lie in making everything more complicated, but in transforming it. And perhaps that is also the greatest philosophy hidden behind modern aviation, that a system only truly matures when beneath its enormous and complicated appearance. Among the thousands of systems that appear complicated within modern aviation, what keeps every flight safe day after day is not technological chaos,